Okay, hello everyone. So there's some slight glitch with my gadgets. So today we're going to continue with our rules of differentiation topic. Okay, so now we try. Okay, let's just recap. So for f prime, it's mean first derivative. Okay, that means it just been derived for one time. So f prime, f double prime, x. Okay, this one should have x as well. It is called second derivative, which means it has undergone 2 times of derivation process, and so on. F triple prime is third derivative. Okay, so now we try to answer example 8. Okay, just for example, okay, let's say we have fx, okay, my writing is too bad. Fx is x cubed, so f prime x or dy dx is we derive x cubed should be 3x squared. And then how to find f double prime? Okay, derive 3x squared and you will get 6x. And how to get f triple prime x? Derive 6x and you will get 6. Okay, this one should be derived df over dx. So this is kind of d square f over dx square, and so on. Okay. Okay, so now let's look at example 8. Okay, what is the question for example 8a? Okay, fx equal to 3x cubed plus 5x squared plus 6x. Okay, derive it for one time and you will get 3 times 3, and this one should be x squared, which is x to the power of 3 minus 1, and you will get x squared plus, I hope you will get the gist of deriving by now, 10x plus 6. Okay, and the question wants us to find until f triple prime x, right? So f double prime is 18x plus 10. F triple prime is 18. Okay, easy peasy. Okay, now let's look at example 8b. Okay, so for example 8b, the question is f prime x. Okay, so I think it is not f prime x. I think it is fx. Okay, fx is x squared. Okay, x squared minus 7x minus 8 over x plus 1. So how can we answer this question? For this type of question, you have to use the quotient rule. The quotient rule. When should you use a quotient rule? When you have to do a division, or when there is division or pecahan. When you have pecahan, you have to use this quotient rule. Okay. Okay, let's look at the let's recap back. Okay, so for quotient rules, the formula is here, or it can be rewritten like this: vu prime minus uv prime over v square. Okay, well, this we should only use quotient rule when there is a division. Okay, when to use product rule? When it is let's say we want to find the f prime x of this kind of equation. Okay, when the okay, when should we use product rule? When we want to find the derivation for this kind of equation, when two equation is multiplied together. But for quotient rule, you use it only when there is a division or pecahan. Okay, so this can also be simplified as uv prime plus vu prime. Okay, I hope that is settled. So to use quotient rule, u here should be x square minus 7x minus 8. U prime is 2x minus 7. So for v, it should be x plus 1, and v prime is 1. When because you only have to derive x, and you will get 1. Okay, so I'm gonna rewrite the formula again. The formula is vu prime minus uv prime over v square. So it should be xv, okay, x plus 1 times u prime 2x minus 7 minus u x square minus 7x minus 8 times 1. Okay, over v square. V square is this one. So x plus 1 square. Okay, so now this looks very complicated, but we will try to multiply this one by one. Okay. Okay, so and then this you should get 2x square minus 7x plus 2x minus 7. Okay, minus x square minus plus minus you get plus 7x plus x over x plus 1 square. So looking at this, can you you can cancel 7x. Okay, and then 2x square minus x square, you will get x square plus 2x minus 7 plus 8, you will get plus 1. X plus 1 square. So can you simplify this? Of course you can. X square plus 2x plus 1 can also be factorized like this. X plus x plus 1 square, and okay, so the answer is what, guys? X plus 1 square over x plus 1 square. If the answer is 1, 1. Okay, 1. So f prime x of this equation, you will get the answer 1. So what do you think the answer for f double prime x? What? There is no constant x here, so it should be 0. And f triple prime x also 0. Okay. Okay, so now let's move on to the next slide. Okay, for the derivative of sometimes in exams you might have to use the definition of the derivative to determine the derivative y equal to sin x. Of course, the derivative of y to sin x, there is a formula, there is a table, and you can memorize that table, but sometimes you have to find the derivative using the basic definition of limits. Okay, so now let's just recap here. So let's say this is a basic trigo. Okay, this is B, A, and C. So sin theta is what, guys? A over C. So this is theta, okay? Okay. And cos theta is B over C, and tan theta is A over B. Okay, so now let's look at this example here. Use the definition of the derivative to determine the derivative of y equal to sin x. So in this part here, fx is what? Fx is sin x. So fx plus h is what, guys? You can guess it by now, sin x plus h. So rewrite this equation here into to be like this. Okay, fx plus h minus fx is sin x plus h minus sin x over h. So how come from this part here you have this? Okay, this is a basic trigo identity. Okay, just recap. Sin A plus B is equal to sin A cos B plus sin B cos A. Okay, this is not cos, okay? This is not cos. This is cos H. Cos H, not cos. Okay, in case any of you confused. Okay, so from sin x plus h, we can manipulate it to be this sin x cos h plus cos h sin x minus sin x over h. So for this part here, we try to together. Okay, I think there is some mistake in this equation. Okay, we try to do it in our own way. Okay, so sin x plus h is also sin a plus b equal to sin a cos b plus sin b cos a. So let's rewrite it here. Okay, just gonna scratch this out. Sin x plus h is also sin a plus b sin a cos b plus sin b cos a. So it should be sin x cos h plus sin h cos x minus sin x over h. Okay, if you're not clear, I think you should rewrite this on a paper. Go grab a paper and a pen, and I hope after you rewrite it, it will become clearer to you. Okay, just by looking at this equation like this, it will not make any sense. Okay, so now then we try to factor in together everything that have sin x in it. Okay, so sin x here, and whereas we got sin x, so okay, and then we will get like this. So sin x cos h, sin x multiply by cos h minus 1 over h, and then this one limit h as it approaches 0 for this part here, sin h cos x over h. So divide it into 2. Okay, next, so we try to solve the limit one by one. So limit h approaches 0 for sin x, and limit h approaches 0 for cos h minus 1 over h, plus limit h approaches 0 for sin h over h, and limit as h approaches 0 for cos x. So for there is a formula here for limit theta as it approaches 0 for cos theta minus 1 over theta. The answer should always be 0. And for limit sin theta over theta, the answer should be 1. So this one here, cos h minus 1 over h is the same like this, right? H here, h here, h here, and here, theta, theta, theta. So can we declare this as 0? Yes, we can. But if there is x, let's say as x approaches 0, and this is cos h minus 1 over h, can we use that? No, because this is only for x function. And then for this, as limit h approaches 0 for sin h over h, we can use this formula. So this should be 1. Okay, so limit h approaches 0 for sin x times 0 over limit approaches 0 for cos, as h approaches 0 for cos x times 1. So if you try to solve this here, the answer should be 0. Why? Because this is a two totally different function. Oh, sorry. It should not be 0. Okay, because whatever the answer here, when you times 0, you will get 0 here. Okay, that's why it becomes 0. So for this part here, cos x times 1, you will get cos x. So this is the final answer. So for this section here, limit sign, example 9, the answer is, you can watch the solution and the steps on how to solve it at this link. Okay, till next time. Okay, bye guys.